Hello there everyone, my name is Crazy Caleb and welcome to Polybius Square. This is a module that I made personally. It is the second module that I've made, and I did record a tutorial for this earlier, but I did actually code this wrong, so I'm going to re-record this again. So, this is the way the module looks. We have a series of 12 different characters on here that we can interact with, and we have a display that has two 5-digit numbers in this case. They will always be ranged from 1 to 5 for each of the digits. There will never be anything outside of that range. So, let's get into how this module works. So this module is very similar to like Playfair Cipher in a way, or rather it's not Playfair Cipher, but it's just using a grid cipher that we have here. And what we need to do here is we need to figure out which 5 letters we're going to be pressing. It's a bit similar to the sense of Caesar Cipher, but there's a little bit more work that you need to do behind that. So, in order to figure out our solution number, we're going to take the sum of all 5 numbers. We're going to add the sum of all characters in the serial number. Letters are, of course, equal to their numeric position of the alphabet, multiplied by the total number of batteries, and then we're going to take the sum of all digits in this total, which this is the bit that I didn't code for a while this time. So, let's take a look and let's see what we have here. So, one thing that should be cleared up is that all of these are in base 10, even though that they can only appear in the range of 1 through 5. So this is base 10. So what we're going to do is we're going to pop out a handy-dandy calculator here. Calculator. Let's do this. So we're going to add 55 plus the 34 plus the 45 plus the 12 plus the 54. We're now going to go to the serial number, and we're going to add up all the characters here. Quebec is 17, 3, 9, 14 for November, 2 for Bravo, and 0 for, obviously for 0. Now what we're going to do is we're going to multiply this by the amount of batteries that we have on the bomb, which in this case is going to be 1 battery right here. That stays the exact same. Now the part that I didn't explain last time. We're going to take the sum of all digits in this total. So we're going to take the digital root, but we're not going to take the entire digital root. So we're only going to do 2 plus 4 plus 5, and then take the least significant digit of the total. So we're only going to add up the numbers that we get from the first bit after the multiplied by the total number of batteries. And now we're going to take the solution number, which in this case will be the least significant digit of the total, which will be 1 in this case. So 1 will be our answer. So now we need to go down to the other bit here. So now, in order to solve this module, what we need to do is we need to solve a Polybius square. The letters on the table are converted to letters based on their location on the 5x5 grid. So the first number represents the row, and the second number represents the column, which in this case, as you can see here, we have numbers and columns, numbers in rows and columns, and what we need to do is we need to find the intersection between each of these when highlighting the rows and columns. So that's what we're going to do, and the top left bit of each of the grids here represents the solution number that we get. So in this case, since we're using 1, since we got 1 as our solution number, this will be the square that we use. This will be the 5x5 grid that we use. And one other thing that's very important to mention is that, as you can see, some of these squares are the 1 through 5 are sorted a bit differently per column and row. In this case, as you can see, with square 0, it's normally 1, 2, 3, 4, 5 from left to right for columns, and it's 1, 2, 3, 4, 5 top to bottom for rows. However, in this case, as you can see, they are completely differently ordered. In this case, 4, 1, 5, 2, 3, 1, 4, 5, 3, 2. It's a bit wacky, but that's going to be the way that works. That's the only real thing that you need to pay attention to. And finally, one other thing that needs to be mentioned. The letters I and J are interchangeable, but only one of the 2 letters can show up on the keypad at once. If you happen to get either I or J, both of those are acceptable solutions, but only one of them will appear on the module. So that's all we simply need to do. So now, let's go into the module here. 5, we're going to do the first number represents row, second number represents column, and we're just going to find all 5 of these letters here. So 5 and 5 is going to be November, 3 and 4 is going to be whiskey, 4 and 5 is going to be a Charlie, and 1, 2 is going to be a Kilo, and then 5, 4 is going to be a Mike. Now, the way that you're going to know you're at least somewhat correct anyways, at least you're on the right starting point, is if you happen to have all 5 letters present in each of these 12 buttons. So, November, Whiskey, Charlie, Kilo, and Mike. And just like that is a solved module. So, let's go over one more example. That's all there really is to this mod. It's just making sure that you understand that, hey, when they want you to take the sum of all digits in this total, it's only going to be focusing on taking the digital root of the first time. So in this case, 245 was our first number here. We got 11 from that total. Our answer was not 2, but rather it's 1 because we're going to take the least significant digit. That's the way that works. So let's take a look at one final example. This module is very straightforward as it was implemented. This module really didn't have much else to it. And yeah, that'll be it. So let us have a look at one last example whenever it decides to load. All right, let's get into it. Yeah, overall, a very simple process to do. There's nothing too hard to do it, just nothing too hard about it. Just make sure that you know that if there was any sort of confusion, these numbers are not base 5 whatsoever. There's no mention of base 5, and there's no mention of bases in this mod whatsoever. So, let's take a look. So, we have 42, 14, 22, 21, 45, and one of the nice things that you can check immediately is if there is no batteries on the bomb, then you know for immediately you're using table 0. You already know. So, but in this case, we actually do happen to have a series of different batteries, so therefore we're going to be good. Now we're going to add all the characters in the serial number here. So 10, 12, 5, 23, 17, and 3. And then we're going to multiply this by, this should be a lot bigger. Hold on. 42, 14, 22, 21, 45. Let's do some of the serial number digits again. 10, 12, 5, 23, 17. I probably typoed somewhere, and then now we're going to multiply this by the total amount of batteries, which in this case is going to be 5. Okay, now we're going to add all of this stuff up together. So we've got 1 plus 0 plus 7 plus 0, which in this case is just going to result in 8. That is the least significant digit of this total here, so therefore that's going to be our answer. Now we're going to use table 8 here, and we're going to use 42. So 42 is going to be I or J, and in this case, as you can see, we happen to have I present on the module, but no J, so therefore this is going to be part of our solution. And one other thing that I should mention, the module will not give you a strike until you have inputted 5 keys. That's the way that works. So I, we get 1, 4 is whiskey, 2, 2 is tango, 2, 1 is uniform, 4, 5 is a foxtrot, and just like that is a solved module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.